everyone. Let us see how to calculate number of insulator disc required for a particular kV of the transmission line. So before going to calculate this number of insulator disc required for a transmission line, we should know what is the insulator and what is safety factor. So first let us see what is insulator. So insulator means in the tower, that is in that electrical tower, we are having the disc, right, that is called insulator. The main purpose of that insulator is it provides the necessary insulation between the line conductors and the towers. That is, it is used to separate the current flowing through the conductor is called line conductors, and the conductors are normally supported by the towers. So to separate line conductors and the towers, the insulators are provided in between the line conductors and the towers. So the main purpose of this insulator is to prevent any leakage current flow from conductors to the earth. So if the insulator is not provided, what will happen? The current flowing through the line conductor is flowing through the earth through the tower. So to prevent that flow of leakage current from the conductor to the earth, the insulator is provided. This is the insulator. So normally this insulator is connected between the line conductor and the tower structure or pole or support. That is, the transmission line is supported by this pole. So that's why it's called as the support. The insulator is normally provided between the line conductor and the support. Main reason is the current, leakage current from the line conductor is restricted to flow to the earth through this tower by means of this insulator. So it prevents the leakage current flowing between the line conductor and the earth through the tower structure or the pole. This is the main purpose of insulator. Now the next one is how to calculate the number of insulator disc required for a particular kV of the transmission line. So normally the transmission lines, the kV ranges are 11 kV, 33 kV, 66 kV, 132 kV, like that. That is, the kVs are normally multiples of 11s. And now let us see. You can go and view the tower structure. In that the top of the tower, the line conductors are connected through with the help of the insulators. So the insulators are having the more number of discs. So in each and every disc having the voltage rating of 11 kV. So nowadays 22 kV a disc also available. So for this calculation only we are taking the number of 11 kV disc required for a particular kV of the transmission line. So for that, before that, we should know what is safety factor, because this safety factor is one constant value. This constant value is multiplied with the number of added with the number of discs, so that we can prevent the breakage of that particular insulator. So for that purpose the safety factor is used. So the safety factor definition is puncture strength with the flashover voltage, or the safety factor is equal to breaking stress to the working stress. So what it means, it is nothing but the safety factor that should be normally more than 1, that is greater than 1, or highest value. So why we want to provide the safety factor of the insulator is highest value means, if you are providing the highest value, there is any problem in that insulator, means what will happen, automatically in the insulator one flash will occur, that is called flashover voltage. That is, the short circuit will occur in that particular insulator, that is called flashover. So before going to breakdown of the particular insulator, we are getting the flashes from the insulator. So that is the normal definition for the safety factor. So the safety factor that should be highest value. Why that highest value is needed? That is, the under abnormal conditions, the flashover occur in the insulator instead of complete breakdown. That is the puncture. So this is the meaning of safety factor. Normally the safety factor for the insulator that should be greater than 1, the best value is the 10 is the safety factor. It is 10. If you are using the 10 as the safety factor means we can get better operation from the insulator. We are getting better performance from the insulator. So now let us see how to calculate this one. So to calculate the number of insulator disc required for the particular transmission line, the formula will be number of disc required is equal to line voltage divided by root 3. That is, normally the 11 kV is nothing but 11 kV, 33 kV, 66 kV, 132 kV. These are all the line voltages. But at the time of calculating the number of disc required for a particular transmission line, we need the phase voltage. So that we are going to convert the line voltage into phase voltage. The formula will be line voltage, the given voltage divided by root 3 into, that's divided by voltage of one insulator disc. Already I said that the insulator disc having the voltage range of 11 kV normally, and here we are also using the 11 kV. So now we are going to calculate the number of discs required for 11 kV transmission line. So already we know the formula. The number of discs required is equal to what is the given line voltage divided by root 3 and into the voltage of one disc, insulator disc will be 11 kV. So simplify this values, we can get 0.577. It is approximately equal to 1 because the 0.5 discs are not available. Only the discs are 1, 2, 3, 4 like that, the full numbers. So that we are approximating the factor 0.577 into 1. So already said that the safety factor that should be greater than 1. Here we are going to consider the safety factor value is 1 and also 2. That is equal to 1 and greater than 1 is 2. So the safety factor is nothing but is used to increase the withstanding capacity of the insulator. That is, the insulator, one of the main properties of the insulator is it should withstand the maximum stress, so that capacity should be maximum. So to improve the capacity or increase the capacity of the insulator, here the safety factor will be used. So first we are taking the safety factor as 1, so that the number of discs required is equal to, here already calculated value is 1 and the safety factor value is 1. So now that number of discs required for the 11 kV line voltage is nothing but it is the 2. Suppose I am using the safety factor is 2 means we are getting the value is 3, right? So the number of discs, normally the number of discs used for the 11 kV transmission line supported by the particular tower is 1 disc or 2 discs. Both of them are used. So this is the number of discs required for 11 kV transmission line. For 11 kV transmission line, the number of discs required will be 2. So here see this diagram. So this is the 11 kV line. So insulating disc, number of insulating disc will be 2 provided in between the line conductor and the pole. For a 33 kV transmission line, how to calculate the number of discs is equal to 33 kV is the line voltage of the transmission line divided by root 3 into the one insulator disc voltage value is 11 kV. So after simplification, that value is 1.732. So that fraction is approximated into full value. It is approximately 2. Already I said that the number of discs is calculated by including the safety factor. So already calculated value is 2 plus, now I am taking the safety factor as 1, so that 2 plus 1 is equal to 3 discs. Suppose if the safety factor is greater than 1 means let us assume the safety factor value is equal to 2. So what is the number of discs required is equal to calculated number of disc value is 2 and plus safety factor now consider is 2. 2 plus 2 is equal to 4 discs. So the number of discs required for the 33 kV transmission line is nothing but 3 discs or 4 discs. So these are all the number of discs required for the 33 kV transmission line. So you can see the tower it is having 3 or 4 discs. From that number of discs itself we can say that particular transmission line running is, it is 11 kV or 33 kV depending upon the number of discs used in the particular tower section. 33 kV transmission line, there are 3 discs are required. So here see this is 33 kV line. Between the line and the pole there are 3 discs will be used. So for 66 kV transmission line, now the number of discs required is again the line voltage divided by root 3 into 11 kV. So the simplification we are getting the 3.464. So approximate that value is into 4. So now we are including the safety factor with that 4. Calculated disc value 4 plus 1 is equal to 5. And again if you are taking the safety factor as 2 at that time, the number of disk value is increased by 1, that is 6. So for 66 kV transmission line, the number of disks required is 5 disks or 6 disks. 66 kV transmission line, there are 5 disks are used, 1, 2, 3, 4, 5. So here from the we can see the tower structure. Depending upon the number of disks, we can easily see this is the 11 kV transmission line, or 33 or 66 kV. So for 66 kV, 5 disks are used here. For a 132 kV transmission line, the number of disks required is equal to the line voltage 132 kV divided by root 3 into 11 kV. This is the voltage value of one insulator disk, and we are getting the value is 6.93, approximate 6.93 as 7. So now we are going to include the safety factor with this calculated value. So the number of disks required is equal to 7 plus, if you are taking the safety factor as 1, finally the number of disks required will be 8. Suppose I am taking the safety factor as 2, calculated number of disks 7 plus safety factor is equal to 2, so 7 plus 2 is equal to 9. So the number of disks required for this 132 kV transmission line is 8 disks or 9 disks. So these are all the calculation for calculating the number of disks required. And for a 132 kV transmission line, 8 disks are used. So here 1, 2, 3, 4, 5, 6, 7, 8. These are all the 8 disks are used for carrying the 132 kV transmission. Disk for 2 different types of insulator. So normally there are pin type insulator, shackle type, strain type insulator, string insulators are available. So normally in that strain and string insulator are used for high voltage application. So the number of disks required for this strain and suspension type or a string insulator are calculated here. So before that we see what is string, and so this is called string insulator. The insulating disks are hanged vertically. So the vertical position of this insulator disk, number of insulators joined together, and the position is in vertical, means this is called suspension type or string insulator. And the disks are provided in horizontal position. It's the same as string insulator, but the position is horizontal. So this is called strain insulator. For a string and strain insulator, the number of disks will differ depending upon the voltage rating of the transmission line. So this is the rated voltage: 33 kV, 66 kV, 132 kV and 120 kV. So here for 33 kV, that disk required for strain type insulator is 3, and suspension insulator 3, both are same. For 66 kV transmission line, number of disks required for that strain type insulator, horizontal position of the insulator will be 5, and suspension type 4. And for 132 kV, 9 disks for strain and 8 disks for suspension type insulator. And 220 kV, there are 15 disks required for strain type and 14 disks required for suspension type. So normally the number of disks required for suspension type is less than 1 as compared to the number of disks used in strain type insulator. So already we have seen the how to calculate the number of disks required for the particular kV of the transmission line. Okay, thank you. Friends, subscribe our channel AAA Encyclopedia for learning all basic concepts comes under electrical and electronics engineering, and enhance your knowledge. Thank you for watching this video on our channel AAA Encyclopedia.